Hi, I'm Science Girl. Welcome to my channel. Today I'm making calcium acetate out of acetic acid and calcium carbonate. I choose to use oyster shells when making calcium acetate because I find that the end result is less contaminated. This video has taken me over 2 months to put together. Since this is my first video, I didn't really know how to edit. I also kept getting distracted, but we're all here now. Please remember to like and subscribe and provide any feedback. Now let's get started. My dad really likes oysters, so we always have a supply of them at home. As you can see, the shells have barnacles and algae on them. Scrub off the algae using a scourer, and then flick off the barnacles using the screwdriver. As you can see, the shells on the left have gone through the process twice, whereas the shells on the right have been through the process multiple times, so they have less contamination. I choose not to crush up the shells because I prefer to have the shells together. When crushing up the shells, the liquid looks more contaminated. Here is a closer look at the shells. Cleaning vinegar has 10% acetic acid and white vinegar has 5% acetic acid, with the remaining being water. Using cleaning vinegar has less water to evaporate. Place the oyster shells into a beaker. Next, add 500 milliliters of cleaning vinegar. As you can see, there are numerous bubbles. These bubbles are carbon dioxide. Place the beaker in the fridge. The reason why this goes into the fridge is because, unlike salt, it is more soluble when it's cooler. Where the hotter salt is, the more it dissolves. 24 hours later, take the beaker out of the fridge. Mine have been in the fridge for over 48 hours because I've been busy with school. As you can see, the shells have dissolved, and some have dissolved more than the others. It's hard to believe that the smaller ones were once a full oyster shell. Filter the cleaning vinegar, which is the liquid that the shells were in before. As you can see, I converted the liquid from the beaker into a container. This is the filtered water. As you can see, it's still a bit cloudy. This is all the contamination. White particles and dog fur are clearly seen. Using the filtered cleaning vinegar, pour into a container and put into an appliance to evaporate the liquid. I use a desiccator. Here are some pictures which I took hourly throughout the process. Leave the container in overnight or however long it takes to evaporate. To find out the yield, scrape out all of the content. After scraping it off, I see this grey powder thing. I don't know what it is, but it could be silica. Next, weigh the content on the scales. Then record the yield. I got 20.17. Add 100 milliliters of distilled water. Once 100 milliliters of distilled water has been added, stir. The liquid is very murky. Black particles and the calcium acetate are seen. Once the calcium acetate has been dissolved, place in the fridge. As you can see, there are still black particles on the bottom of the beaker. After staying in the fridge overnight, filter again. Use water to secure the filter paper. Use water to wash down the excess and then pour into the funnel. This took a while to filter, but what you can't see is that there are many particles stuck on the filter paper. Place the container in the desiccator and leave to evaporate. After leaving the container in the desiccator overnight, you can see that the liquid has evaporated. There is a slight discoloration in the calcium acetate. Scrape out the content. I use the end of a spoon. Pour the excess into a bowl. Continue scraping until the container is empty. Crush into a fine powder. Once it is a powder, pour into a container, remembering to scrape off any parts that are stuck to the bowl. To calculate the final yield, measure again. I previously measured the container, which was 7 grams, so whatever my end result is, I will minus 7 grams.